13.8 billion years ago, the universe was born. Today, a telescope 1.5 million kilometers from Earth is watching its earliest moments. JWST's launch miracle. How this telescope became the universe's ultimate eye. Imagine building the most powerful telescope ever made, then folding it like origami and launching it into space with 344 single points of failure. One tiny mistake, and the entire mission is gone forever. That's exactly what happened on December 25th, 2021, when the James Webb Space Telescope launched. The telescope traveled 1.5 million kilometers from Earth to a special point in space called Lagrange Point 2, where it could keep the sun permanently behind it. Then came the most terrifying part, the 29 days of deployment. JWST had to unfold a 6.5-meter mirror made of 18 hexagonal segments, each coated with a layer of gold just 100 nanometers thick. Next, it deployed a 5-layer sun shield the size of a tennis court. Each layer is thinner than a human hair, yet together they block heat from the sun, Earth, and Moon. Without this shield, the telescope would heat up to 85 degrees C, but with it, the instruments stay at an icy 223 degrees C, perfect for detecting faint infrared light from the early universe. And if that sun shield failed, the telescope would instantly become useless. No repairs, no astronauts, just a $10 billion piece of space junk drifting through space. But against all odds, everything worked perfectly. And when JWST finally opened its golden eye to the universe, the discoveries began to shock the world.
Oldest galaxies ever seen, Mom. Z14 and JWST. Z14-0 challenge everything. JWST didn't just look far into space. It looked impossibly far into the past. In 2024 and 2025, scientists confirmed a galaxy called JWST Z14-0. Its redshift is 14.32, meaning we see it as it was only 290 million years after the Big Bang. Then in early 2026, JWST pushed the record even further with MOM, Z14 at redshift 14.44. That's just 280 million years after the universe was born. The light from these galaxies traveled 13.5 billion years to reach us. But here's the real shock. At redshift 14, the universe was only about 2% of its current age. Yet these galaxies already contain hundreds of millions of stars. They are far brighter and more massive than our theories predicted. Some nearly 100 times more luminous than expected. JWST spectroscopy even detected oxygen and other heavy elements. Proof that earlier stars had already lived, exploded, and enriched the cosmos, which leads to a stunning possibility. The first stars may have formed just 100 million years after the Big Bang, far earlier than our models predicted. In other words, the early universe wasn't slow and quiet. It was violent, chaotic, and building galaxies at breakneck speed. And now, cosmology may need a complete rethink.
Little red dots, LRDs, the universe's biggest mystery objects. Everywhere the James Webb Space Telescope looks in the early universe, it keeps spotting something strange. Tiny glowing points called little red dots. Thousands of them appear in the first 1 to 2 billion years after the Big Bang, shining brightly in infrared light. But these objects are bizarre. Most little red dots are about 100 times smaller than the Milky Way, yet some shine as brightly as full-size galaxies. Their spectra reveal extremely broad hydrogen emission lines, a signal often linked to matter falling into powerful black holes. That's why many astronomers think these objects could be baby, supermassive black holes, growing incredibly fast inside young galaxies. Some of them behave even stranger. Objects like Virgil look fairly ordinary in visible light, but in infrared they suddenly appear extremely bright, as if something massive is hidden inside thick clouds of gas and dust. Even more puzzling, these little red dots seem to peak around 600 million years after the Big Bang, then mostly disappear after about 1 billion years. That suggests they might represent a short but crucial phase of galaxy evolution. So what are they really? Hidden quasars, runaway black holes, or something we haven't even imagined yet? One thing is clear: these tiny red dots may be revealing how the universe built its first supermassive black holes.
Monster stars in population 3 proof, giants that built the universe. Before the first normal stars existed, the universe may have been filled with monsters. Astronomers call them population 3 stars. These were the very first stars ever formed, made only of hydrogen and helium. No carbon, no oxygen, no metals. Those elements simply didn't exist yet. Because of that, these stars could grow insanely massive, sometimes 300 to 1,000 times the mass of our sun. But giants like these don't live long. Population 3 stars burned extremely fast and survived only a few million years before dying in gigantic explosions called hypernovae. And those explosions changed the universe forever. They created the first heavy elements: carbon, oxygen, iron, and nitrogen, the building blocks of planets, galaxies, and life itself. In fact, every atom of iron in your blood was forged in the death of ancient stars like these. Now, the James Webb Space Telescope may have finally found their fingerprints. In observations from 2025 and 2026, scientists detected unusual nitrogen excess and chemical signatures in extremely ancient galaxies. These patterns suggest the influence of those early monster stars. Some theories even propose that the first stars might have been dark stars, powered partly by dark matter annihilation. Whatever the truth is, these stars lived fast, died young, and helped create the first black holes in galaxies. Without them, the universe we know wouldn't exist. Alien worlds and life hints, exoplanet atmospheres full of surprises. The James Webb Space Telescope isn't just looking back in time, it's also searching for life on alien worlds. JWST studies exoplanet atmospheres using a technique called transit spectroscopy. When a planet passes in front of its star, a small amount of starlight travels through the planet's atmosphere. Different gases absorb specific wavelengths of light, allowing scientists to detect molecules like water vapor, methane, carbon dioxide, and sulfur compounds. And the results are already surprising. One of the most intriguing planets is K2-18b, located about 120 light years away and roughly 8.6 times the mass of Earth. Scientists believe it may be a Hycean world, a planet with a hydrogen-rich atmosphere and possibly vast global oceans. JWST has detected carbon dioxide and water vapor in its atmosphere. Even more shocking, scientists may have found hints of dimethyl sulfide. On Earth, this gas is mainly produced by ocean plankton, which is why the possible detection stunned researchers. But it's important to be careful. This is not confirmed evidence of life yet. NK2-18b isn't the only strange world JWST has revealed. The telescope has also found lava planets, carbon-rich atmospheres that defy formation theories, and giant worlds where it may literally rain diamonds. With every new observation, JWST is getting closer to answering one of humanity's biggest questions. Are we alone in the universe? Impossible bright galaxies at universe's edge. Cosmology crisis deepens. The James Webb Space Telescope keeps finding galaxies that shouldn't exist, not because they're rare, but because they appear far too early in the universe. JWST has discovered hundreds of galaxies at redshifts above 10 to 14, meaning we see them when the universe was only a few 100 million years old. But here's the problem. Some of these galaxies already contain around 10 billion times the mass of our Sun within the first 500 million years after the Big Bang. To grow that fast, they would need star formation rates of 100 to 1,000 stars every year. For comparison, our Milky Way forms only about 1 to 2 stars per year. Even stranger, many of these galaxies are up to 100 times brighter than our models predicted. Scientists are now scrambling for explanations. Maybe early black holes triggered intense bursts of star formation. Maybe dark matter behaves differently in the young universe. Or perhaps gas collapsed much faster in dense cosmic regions. JWST has also spotted strange objects like blue monster galaxies and even runaway black holes racing through space. All of this suggests something shocking. The early universe may have evolved far faster and more violently than we ever imagined. And if these measurements hold, the entire timeline of galaxy formation may need a serious rewrite. 2025 to 2026 latest shocks, from new moons to universe inside black hole, the James Webb Space Telescope keeps delivering shock after shock. In 2025 and 2026, JWST revealed stunning new details of Uranus, including its glowing rings, turbulent atmosphere, and even the discovery of a new small moon. It also captured breathtaking images of nebulae filled with thousands of newborn stars and detected complex organic molecules drifting through interstellar clouds, the raw ingredients of life. But the biggest surprises come from the early universe. JWST has discovered some of the earliest supermassive black holes ever seen. One of them already had around 10 million times the mass of our Sun, yet existed only 570 million years after the Big Bang. Scientists are still trying to understand how something that massive could grow so quickly. The telescope has also analyzed ancient interstellar comets, spotted far more early supernovae than expected, and mapped huge regions of the universe in incredible detail. All of this is forcing astronomers to rethink their theories. Some researchers even explore wild possibilities, like direct collapse black holes forming extremely early, or the controversial idea that our universe might exist inside a giant black hole. Whether those ideas hold up or not, one thing is clear. JWST is rewriting our understanding of the cosmos in real time. And with more observations coming in the next mission cycles, the biggest discoveries may still be ahead. So tell me in the comments, which JWST discoveries shocked you the most?